Hello all and welcome to Chapter 19. In Chapter 19 now we're going to look more closely at those fossil fuels, their impacts, and energy conservation. So here we go. So we're going to help to understand our energy sources. Coal, our use of coal and natural gas and crude oil, so we'll be able to compare those three to see which one is more efficient. We'll look at oil sands and other alternative fossil fuels. We'll consider the environmental impacts of fossil fuels. We'll look at political, social, and economic aspects. I might have you read over that section as part of this so that we can cut this chapter down a little bit more quickly. And then we're going to look at conserving energy, enhancing efficiency. All right, look at this. This is the damage that is done by our mining coal and fossil fuels. This was all once livable land with trees on it and plants and animals, and we are mining the land for the fuel source. So this is the damage that we can see done physically on the surface of the earth, but it's certainly not the extent of the damage when we consider the pollution and the climate change that goes along hand in hand with our use of fossil fuels. To help make this go a little bit faster, I am going to ask you to please read the central case study on page 519 through page 520 in your textbook, and please you can get the notes on Rediker. Add notes to the PowerPoint that you see here, the oil sands and the tar sands. Please make sure that you add those notes. This is the map that corresponds with that case study so that you can see where they're talking about. And this slide is also part of that case study as well. We will be looking at the pipeline, which I believe that article does take a look at the pipeline as well. So this talks about the pipeline that has been heavily in the news lately, especially with our new president and the laws that he's passing with that. So please make sure that you read that on your own. And these are the slides that are going to affect that. Think of that Ogallala, which I still can't say, aquifer that this oil spill could affect. This is the main aquifer for the United States, so make sure that you're taking notes on that as well. Okay. So humanity has devised many ways to harness the renewable and the non-renewable forms of energy that are available on our planet. We use energy to heat and light our homes, to power our machinery, to fuel our vehicles, to produce the plastics and pharmaceuticals, synthetic fibers, and to provide the comforts and conveniences that we are accustomed to. So when we look at where does this energy come from, most of our energy comes from the sun. We can harness the energy from the sun's radiation directly by using solar power technologies. Solar radiation, when you look at it, helps drive our winds and our water cycles. It enables us to harness the wind power and the hydroelectric power. Sunlight drives photosynthesis, which is responsible for the growth of our plants, in which we get our wood and other biomass for fuel sources as well. When organisms die and they're buried in the sediments and they store chemical energy that eventually will be transferred into fossil fuels. We know that fossil fuels are highly combustible substances that are formed from the remains of these organisms from the past. And we rely on three main fossil fuels, one in the form of a solid, and that's coal, the other in the form of a liquid, and that's oil, and the other in form of a gas, and that's natural gas. A great deal of energy also comes from our Earth's core, geothermal power. That's what it's referred to as. There's energy that results from the gravitational pull of the moon, and we're just beginning to harness the power from the ocean tides that these forces generate. There's an immense amount of energy that resides within the bonds among protons and neutrons in atoms, and this also gives us nuclear power. So we have a lot of sources of energy that is available to us. Sunlight, the geothermal energy, and the tidal energy are considered perpetually renewable because they are readily available and replenished daily, and we can continue to use them without depleting them. But non-renewable items such as coal and oil and natural gas, these result from ongoing natural processes that took thousands of years to generate. And right now we are depleting so much so, and we're consuming so much that it would take millions of years in order to replace the fuels that we've used. Our accelerating rate of consumption they're estimating, will use up these fossil fuels within just a few decades. So for this reason, we have to look at alternative sources to power our cars, to provide our electricity for our homes, and it needs to be in renewable energy. So here we go. Here's a list that we can see. We can see that our crude oil, our natural gas, and our coal, and even our nuclear energy are all non-renewable types of energy. But our biomass, our hydropower, our solar energy, our wind energy, our geothermal, and tidal wave energy, these are all renewable. So we have a lot more renewable types of energy available to us that we could use. Cleaner and even maybe more effective that is available. What this means is fossil fuels dominate our energy use. So the global consumption of our fossil fuels is now at its highest level ever, and the population is at its highest level ever as well. The high energy content of fossil fuels makes them very efficient to burn. It also makes them easy to ship and to store. And we use these fuels, as we've already said, for transportation, manufacturing, heating, cooking, and to generate electricity. Electricity is a secondary form of energy that is very convenient to transfer over long distances and apply to a variety of uses. And we can think of all the ways that it's used in our homes. Each type of fuel has its own mix of uses as well. For example, oil is used mostly for transportation, where coal is used mostly for electricity, to generate electricity. When we take a look at this graph, this shows the annual global consumption of our fossil fuels. The oil remains our leading source of energy. As you can see, it's represented by the red line, and then coal, and then natural gas. Societies really kind of differ in the way that they use their energy. So if we consider industrialized nations, they apportion roughly about 1/3 of their energy to transportation, about 1/3 to industry, and about 1/3 to all other uses. Where in industrializing nations or developing countries, they devote most of their proportion of energy to subsistence activities such as agriculture, food preparation, and some home heating. Much less is done on transportation. In developing countries, they often rely on manual and animal energy sources as well instead of automated ones. Here in the United States, though, we use 82% of our energy is used and demanded from us. So quite a bit more in the industrialized countries. Let's take a look at this graphic. This is the total energy flow of the United States. Okay, so we can see our energy flow, our products and other uses, imports, oils, natural gas, coal, how much goes to import for that, nuclear, renewable. And look at the way, this is a complex flow system that we see here. We can see coal and nuclear and renewable resources going into energy. We can even see some natural gases. We see some of our renewable resources being used in industry and transportation. Our oil, some of it's exported, but goes directly, most of it goes directly for transportation and some for industry. The electricity that's generated goes for residential, commercial, and industrial. So we can see that major consumption. The gray that we see represents the amount of loss that we get when we use these substances. So obviously, nuclear renewable coal has the most energy that is lost. So we're going to be looking at a map in just a minute. And when we look at this map per capita, we can see the consumption rates of our resources. Citizens of developed regions generally consume far more energy than do those in developing regions. Per person, most industrialized nations use up to 100 times more energy than do the least industrialized nations. So thinking of the United States, and let's go to this picture so that you can see this. So when we think of the United States here in red, it has 4.4% of the world's populations, so relatively small population-wise, but it consumes nearly 19% of the world's energy. Now, as we look around, we can see that some regions have a substantial reserve of oil and coal and natural gas, where others have very few. If we look at the Middle East, that's where most of the crude oil lies. It's also very rich in natural gas. Russia also holds a lot of natural gas in that area, as well as coal. But China and the United States possess the most coal of the nations. So we have a lot that's going there. Obviously, it takes energy to make. We don't get the energy for free. We have to harness, extract, and process and deliver the energy, and to do that requires substantial inputs of energy on its own. Mining oil sands requires powerful vehicles and machineries and roads and pipelines and waste ponds and storage tanks and housing, etc. So there's energy into maintaining and having all of those available. So all of this requires energy. The net energy is the difference between the energy returned and the energy invested. So we want to make sure that we're getting more energy returned than we are investing it. The net energy equals energy returned minus the energy invested. So that's the mathematical equation for it. Energy returned on investment is referred to as the EROI. And it has higher ratio mean, which means that we receive more energy than we reinvest. So that's the good thing. And fossil fuels have historically high EROI. Okay, so I'm going to end this here. We're 14 minutes in, and we will continue this in the next section.